I'll be right back. I'll have to shut down. Right, almost there. Yeah. Okay, as you can see, where's my written? Okay, you can check it if this is correct. So this top left thing is that one because the first number is the color, so it's green. That's correct. The second number is the number. So 0 means 1. There is indeed 1, and this is 2. This is 3. And then the third number is shading. 2 means opaque, and it is opaque. And the last number here is the shape. So that is a Z-pill, that is just shape indeed. And so on. I did all 20. I'm going to wait a minute, I think. Maybe see other people join. And then I'll have a whole story about this, my reasoning. It's about 4-dimensional spaces and everything. And I'm flabbergasted. If this is indeed not having a set and I don't see one, I have to admit that, then I have been wrong. Shocking. And I want to understand what I did wrong. But it is in 4-dimensional space. So I did a wrong reasoning in 4-dimensional space. And I still don't see it. So, but let me get a sandwich and I'll be back. Okay. No, everyone left, according to YouTube. Okay, you still here, Everton? I'll just tell you if you're still there. Now first need to eat my sandwich, otherwise I cannot talk. But you can check the numbers. That didn't work. Let's call it what it is. A card. We have 20 cards. And each card, well, I'm going to work with structs because I'm really not interested in access control at the moment. So the first number in the first column here is the color. The second number is the count. I'll call it count instead of number. Well, it is number, but I'll call it count anyway. So that is the number of shapes here in on a card. It's either 1, 2, or 3. But I'm going to call it 0, 1, or 2. So you have to add 1 to actually get a count or the number. Comment. How do you call these things? Shapes? I guess shapes is good enough. Number of shapes, mine is 1. And then this is 0 is red. 1 is green. And 2 is, what is it? Purple. Doesn't really matter, by the way. It just, the mathematics works just with 0, 1, and 2, so it doesn't really matter what it stands for. But, okay. Add comment anyway. The third column here is 1, 2, 3, the shading. Call it shading. In fact, it would probably be better to make an array of this as well. In a minute. And the fourth is the shape, which we use 0 is, I don't know how to call these things. I'll just call it the pill. This one here looks like a pill from the doctor. And 1 is that one, call that a peanut. And then 2 means that it is this, there's a rhombus, right? Or whatever. And I can't type, really. Array. Too many initializer. That's not good. No, it's 20. What do I do wrong? I think I need another brace here. I mean, if it's not that, then I don't know. Yep, okay. Now we have to make sure that that I filled it right, so I'm going to print it even. All the cards are printed, for which we need IO stream. And we need to be able to print the card. Standard stream reference operator less than standard stream reference s, card const reference card. And that returns OS, and then we just print, say, also something with this. And then we just print everything, card, dot color, comma, card dot count, comma, card dot shading, comma, card dot shape. All as just little numbers. Top out. That didn't work. And less than card size would be a wise choice here, I think. Okay, I'm taking it. It is. I'm paranoid. 20. Okay, now, okay, the story. How do you determine if, I mean, in the case someone doesn't know the game is you put cards down, and each card has each card has 4 characteristics, namely a color, which can be one of 3 different colors, green, red, and purple. And that was the first characteristic, the color. The second characteristic is the number of shapes that you see, which can be also one of 3, namely 1, 2, or 3 shapes. This one has 2, this one has 3 again, etc. That was the second characteristic. The third characteristic is, the shape itself. And we have 3 different types of shapes. I call them a pill, a peanut, and a rhombus. So also 3 possibilities. Then we have the fourth characteristic, which is the shading, which is either no shading, like here, or shaded with stripes, or solid, like this one and this one, etc. The game is then that you put down, I think, 12 cards, and then the first one who sees a set calls out set, and they have to point out 3 cards, where of each of the 4 characteristics of those 3 cards, the characteristic must be the same, so all 3 must be green, or they must be different. For example, this here is almost a set, these 3 here at the top left, because their characteristic color is the same, green, green, and green. Characteristic shading is the same, namely solid, solid, solid. Characteristic count is different, namely 1, 2, and 3. But it's not a set because the fourth characteristic, the shape, is neither the same nor all different. Namely, this is a pill, and then this also had to be a pill, but it isn't. Or one of these pills here could have been a rhombus, then it would also have been a set. How do we do that in mathematics? Let me think real hard. Yeah, each characteristic, to check if one of the characteristics is correct, you just add them and then take the modulo 3. Let me go back to the program. So for a single characteristic, if they are all different, that means you have a 0, a 1, and a 2. That's each characteristic is either 0, 1, or 2. Now we forget about shapes and colors and whatever. They're just 0, 1, or 2. If I add them, we get 3, obviously. And then we do modulo 3. Oh, it means you subtract 3 until you get something that is less than 3, so that gives us 0. Yep. Or in C++ code, we add them and then I do modulo 3, and that equals 0. Now note that if they are the same, 0 plus 0 plus 0, modulo 3, that's also 0. And quite obviously, if they're all 3, 1 or all 3, 2, you get also a multiple of 3. Sorry, a multiple of 3. This is 3 and this is 6. So modulo 3, that is also 0. And if you do any other combination, then you don't get 0. Why is that the case? Well, you could test it out, I guess, with a little program, but you can also reason it. Let's write a little program. So characteristic of a card, well, 0, and you start counting at 0. Run some 0 till 2. And now we do the same thing for characteristic 1 and for characteristic 2. And then we do if, well, let's print it out. Well, let's take bool. Let's call this simply set, as if it is just a set with a single characteristic. I'm going to do C0 plus C1 plus C2 modulo 3 equals 0. And then I'm going to say print, well, all values. C0, there's no commas needed. E2, and then we print if it is a set or not. Can't type anyway. Too many sets. End line. Yep. Make. There's no make. that was an example. So these should be, we have 3 cards, and each card has a single characteristic, and that characteristic runs from 0 to 1, so 0, 1 or 2, so 3 possibilities. So we have 3 to the power of 3 is 27 possibilities. And this is a set because they're all the same. This is not. That's correct. Not. That's correct. Not. That's correct. Because they're neither the same nor all different. See? There's 2 that are the same but not 3. So this is also not. This is a set because now they are all 3 different. And they're not all 3 different. That's a set. This is not a set. This is not a set. This is not a set. This is a set because now they're all 3 different again. Indeed. And again a 0, and they are the same, so it is 1, and this is not a set. So we run over all this. This is not, this is not, this is not, this is not. I'm looking here, right? Not here. This is a set, this is not, this not, this not, this not, and this is a set. And yeah, that matches whatever it is. So the formula works, as you can see. Oops. Now, what does that mean? Sorry, I have to think. Oh, right. I got a little bit confused. All the cards are different, right? So if we have a card with only a single characteristic, then this won't happen because there would only be 3 cards. And the only thing that can happen would be when they were all different. There are no 2 cards with a 0. So the only way to get to actually being able to have one characteristic like this is when you have another characteristic that is then different when there are when something is the same here. So this is one characteristic. Now in the case that we have 3 zeros, for example, we have a card that is green. I need 2 characteristics, I think. Let's say I want to edit this. So this is characteristic 0 of the cards. So this is 1 card, 2 cards, 3 cards, and whether or not it is it can be part of a set with that characteristic, but there must be more characteristics. Otherwise, you would have you cannot have 3 cards that are the same. So it's, every card is different. So we must have another characteristic Now this is characteristic 1 for the same card. So the first one here is 0, then the first one here is the same card as that one. So if this one has 0 here, then this cannot be 0, because that would mean that the first card is 0, 0, characteristic 0 is 1, and characteristic 1 is 0. And then the second card already has characteristic 0, 0, so characteristic 1 must be different. So we can only have a 1 here, or a 2. But no, let's be complete. Let's be complete. So we can only have this. And then this one also must be different, and then also different from that card. So this is the only possibility that we have when we have only 2 characteristics. And now these now are all different. They have to be, because these are all the same. And therefore we have a set of 2 cards. But set of 3 cards where everything is equal, either the same or different. Yeah, but it's still not very interesting, right? You want to have at least 3 characteristics, because now we're also forced to as soon as one is equal, then we are forced to make this one also a match. So I'm going to add even another characteristic, such that it is possible that we do not have a set. Let's see, for example, characteristic 2 here. The first card could be 0, why not? And then this card is already different, because this one has 0 here and 1 here. So it's different from the first card. We forced it to be different by putting these numbers here. So characteristic 2, I can fill in whatever I want. I can make it 0. Oops. I can make this one give, I don't know, 2, and this one also 2, say. And here I could say I'll give them all 2s or all 1s. Now this is not a characteristic. Sorry, this is not a set, because now they're not all 3 different, and they're also not all 3 equal. And this one is, because they're all 3 equal. So now we have, yes, it can be a set for characteristic 0, and also for characteristic 1, and also for characteristic 2. And therefore this is a set. And this is not, because, you know, just like in this case, the color was a set, the count is a set, the shading is a set, but for the shape itself we have 1, 1, 2 or 0, 2, 2. So it's not a set, because it's not a set when just looking at the characteristic shape. Now we can do the following thing. Now we have 3 characteristics. So any given card, for example this card here, sorry, underlying that 0, I can't type. The first card here has 0, 0, 0 for the 3 existing characteristics. And the second card has 0, 1, 2. And the third card has 0, 2, 2. That looks like a vector. And yes, we could put this into a 3-dimensional space. And unfortunately, I don't think I can draw here. I definitely need drawing now. Online drawing. Online drawing, is it possible, or should I just go to pencil. Does it work? Yeah, can draw already. Awesome. Okay, so we put characteristic 0 here. And characteristic 1 here. And then we put characteristic 2 here. And each characteristic has only 3 possible values. So we get something like yep, this one also. So I actually, this is 0 now, and this is 1, and this is 2. Not even putting the 0 here in the corner. Just it's how do you call it? A discrete grid. Okay, now what does it mean if any given characteristic is either the same or all different? Well, if it is the same, then it doesn't change. So if we have a set of 3 cards, oh, by the way, so this is a 3-dimensional space with 27 little cubes, right? It's a cube, and we divided the sides into what am I doing there? We divided the sides into 3 parts. So the whole cube here is 3 by 3 by 3. That gives 27 little cubes. I'm just shading the sides, but of course also in the middle we have little cubes. And in total 27 of them. And then each cube stands for a card. Sorry. All these 27, these are the vectors. 0, 0, 0, 0, 0, 1, 0, 0, 2, and so on till 2, 2, 2. And in total that was 27 of them. Oh, that's not true, because these are supposed to be different cards, but now I have 3 characteristics. You can just look at the first number of each thing, and then you get the same 3 to the power 3. So I was going to look at this thing here, for example. So the first card is 0, 0, 1. Okay, 0, 0, 1. Huh? Suddenly can't draw anymore. A second ago I could draw. Now I cannot draw anymore. Don't you hate sites like this? What the fuck is this? Select. Okay, select stuff. I don't want to select stuff. I want to draw. My God. Huh, we can do it. Finally, go back. Okay, 0, 0, 1, so that's here, right? Make the cube here. Drawing 3D is a bit unclear often, but this little cube here is 0, 0, 1. Or the grid on the back face as well. Okay, and that was this card. 0, 0, 1. The next card is 0, 2, 1. Still draw, yeah. 0 for C0, 2 for C1, and the last one was, sorry, really? Was this one? 0, 2, 1, yeah. 0, 2, 1, okay, that's here. So let's draw the cube, and that's it here. Now you can see that the characteristic 0 is the same, because it is in this plane. You know, see 0 is 0 for both of them. And it is in this plane, in the middle here, because C2 is equal, is 1 for both of them. And C1 is different, so we get two of them here on a line. You could draw a line through it, like this. And that is relevant because which card would make a set with these two? Because always only a single card that makes a set. Well, the only card that makes a set is the card here, the little cube that goes in the middle. AKA 0, 1, 1. And what do we have for the third card? 0, 1, 1. Yay! So we have a set, and that was correct. Now this one is not a set, so let's draw that one as well. That exists of 0, 0, 0. Sorry, that's not true. 0, 0, 0. Yes, it is true. Can I switch color here? Oh, what the fuck? Control Z. You can hope. Yeah. It doesn't even, wouldn't even be too bad to fill it like this. Why not? But how can I change the color of my... that looks green as well now. It's still black. Yeah, something else, I think. I'm afraid you cannot figure that out. And we lost my drawing. Well, really. Yep, you fill it, so everything gets filled. And you think, well, I'll press Ctrl Z, then the fill will go away. Yeah, plus all the cubes that you did draw. Well, very great. 0, 0, 0 is here. I hate sites like this. Should have done it in GIMP. That's 0, 0, 0. And the next card is 0, 1, 2. 0, 1, 2. Is that all the way over here? 0, 1, 2. Yeah, it doesn't let me draw anymore as usual. How did it do that the last time? Click here. That doesn't work anymore. Oh, no, it does. Or not. Well, I'm ignoring what all happens. I just want to draw here. Wibble a bit. Oh. Fuck off. I think we just lost our... yeah, seriously. I should have done this somewhere else. My God, what a horrible experience. Nope. Definitely wants to have a selection now suddenly. That is not working at all. Give up. Fuck off. Stupid site. Graphics. Nothing we can do about it. I have to start over. Maybe still a bit too large. 4 pixels. That doesn't fit, of course. I can maybe move it. Okay, now, so we had the 0, 0, 0, this cube. In the corner here. And then the next one was 0, 1, 2. Oops, suddenly even here now I cannot draw anymore. You couldn't be kidding me. Oh, this is outside my selection. Select none. So what did they say? 0, 1, 2. 0, 1, 2. That's over here. Okay. Now the question, which card will make a set with these two? Well, every characteristic either has to be the same or they must be different. So if you look at characteristic 0, both have characteristic 0 value 0. They are in this plane. So the card that makes a set with this also must be in this plane. And if you look at characteristic 1, they are different. This one has for characteristic 1, it has value 0, and this one has value 1 for characteristic 1. So the third card that makes a set must also be different and must have value 2. And then for characteristic 2, we already have 0 and 2, because the 1 is in the back, so it must be 1. Therefore, the card that makes a set with these two sits here. Yep, then C0 is 0, C1 is 2, and C2 is 1. So they are all different. But why, how does this picture give any insight? Well, if you remember, we were doing modulo 3. So if I repeat this picture in all directions, we have 0, 1, 2, and then 3, modulo 3 is 0. So you can see 3 as if it was 0, and you can see 4 as if it is 1, and you can see minus 1 as if it is 2. If you work modulo, you can just repeat the image. So what I'm going to do is repeat the image in this direction, and that means that this cube appears again here, outside you can see what I mean. Sorry, it's not very clear. Yep, and then this cube repeats over here. Do it like this. And then this cube repeats over here. And so on. After that, now we are at the end of the second cube here. So after that we get again this cube. And if I repeat it on the top as well, and so this was our large cube here. If you repeat it, then this little cube also sits on top here. And I will color these things in. Here's a cube, a little cube. So let's make a mess of it. Make a horrible mess of it. Sorry, I should have done like that. Wait a minute. Deep, pull up. Or maybe I should just say it. So these 4 lay on a line, and the line is infinitely long. If you repeat the thing in all directions, infinitely long, modulo 3, so you just repeat it, then a set is a line. And the reason is that either they are I should do this in 2 dimensions. You see, the characteristic 0 is the same, right? So we might as well only draw this one plane here. Let's do it in 2 dimensions then. We'll make a new one. So now we just have characteristic 0 was the same, so we do characteristic 2, I do here. So 2. C2, C1, and then we have 1, 2, 3 here. And we had a cube here. So can I draw a quick grid? That would be nice. These are straight lines. I just they don't look like it, but they are totally straight lines. How am I doing this? I just don't know. A good drawing program, I guess. And so on and so on. So 0, 1, 2, 0, 1, 2. And then we had in this plane we have one at 0, 0, and then we have one at well, not diagonal but a bit further, and then higher. So oops, we had this one here. Oh wait, I was going to fill it. Oh no, it doesn't work. Not fill like that. Is it like fill? How do you fill the thing? This? Nope. The fuzzy select, I think. The U. Yes. I can even do shift, that's plus, and then we can fill both. About that. Again, that's all we had. But now we have just one side, you know. So now I'm going to, and this was our initial, well, or not, should draw. For some reason I cannot draw anymore. I'm tired of that. What is your problem? Let me draw. Oh, the selection again. Select all or whatever. This was our space. This is our space because we have only the values 0, 1 and 2. But since it's modulo 3, we can do as if this repeats in all directions. So also repeat it here. And repeat it here. And so on and so on. Infinitely far, even above here. Yep. And to that side as well. And to the bottom. And we put in every square, we put exactly the same picture as this. So, in fact, so exact that maybe I'll just copy it. And then paste it. And then put it down everywhere as it were. So does it work? Well, it's not totally at scale, unfortunately, but you get the. Do you get the idea? I'll just put it like that. Okay, this doesn't work. no, 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 no. I'll have to do it like this, I guess. Okay. Let's set the color right. No, wait. I think you had this, and now fill everything. Yeah, there. No, wrong color. Well, you get the idea. So now we had the same, the exact same thing, and really it sucks that now it is like. That didn't work either. So this color. Oh wait, I have a better trick. They did hide everything. Color picker. Nobody knows why, but oh, and now you cannot do that anymore. Color picker. Jesus Christ. No, okay, give up. Assume these things all be the same color. Then the big trick is that this should not have been filled. Big trick is that, as you can see, it is a line. There's a line here. So these three, when repeated, form a line. As soon as you have a line, you have a set. No, sorry, I'll take way too much time. So I'm going to go back to my program, and you have to do the rest in your head, because we're switching to 4-dimensional space anyway now. Already had way too much trouble drawing it in 3 dimensions. Okay, so back to 4 characteristics. The 4 characteristics go in a 4-dimensional space. We have 4 axes. Each axis has 3 possible values, 0, 1, and 2, but we repeat them infinitely. But okay, if you look at one of the cubes, then we have a cube of 3 by 3 by 3 by 3. It's 4 times. And that gives us a total of how many cards? 3 to the power 4, so 81. So we have 81 cards and our 81 little cubes in a hypercube of 3 by 3 by 3 by 3. And if you fill any of those 81 little cubes in this 3-dimensional space, if you fill 3 of them, I mean, then you can see if it is a set, if they form a line. I mean, if you repeat it in all directions, in all 4 directions, infinitely often, then you get a line for a set. And then the question was, how many cards can you have without having a set? So I thought, well, picture a 3-dimensional cube, for example. I can put one cube in the corner, little cube. So now I have 3 by 3 by 3, 27 in total. I put a little cube in the corner, and then a second one next to that, for example, and then that way I built a little cube of 2 by 2 by 2. That way we leave a gap. So you have the big space and divide it in actually asks us. I feel I have a problem explaining it, so I don't know if people can follow it. That's why I'm hesitating. You have to see it in front of you. So it would be much better if I could draw it. But I don't have a good drawing program, so this really sucks. Anyway, I'll just continue coding, I guess. So I'll finish my story for those who can follow it. So I thought if I have a four-dimensional space modulo 3 in all four directions, and you just fill a cube with 16 cards, being 2 times 2 times 2 times 2, then you leave a gap, so you have absolute certainty no line. You cannot draw a line because then you have to go through the empty part that surrounds that cube of 2 by 2 by 2 by 2. And once you have those 16 in that way, I cannot think of a 17th little cube that you can add without making a line. Cannot be above it. Cannot be adjacent to a side, because then it would connect it in the same direction. So it must be completely at the edge in order not to be adjacent to any side, and then you just have a set where all the characteristics are different. The long diagonal. Yeah. So I was like convinced, and I'm almost still convinced, if it wasn't for this example, where I don't see a set, that the maximum is 16. I would have bet money on it, definitely. And now this would be an example of 20 cards that do not form a set. I think that step 1 is that we're going to check that. We checked it as follows. I think I can just delete all of this. Well, I'm not sure if it is smart to call them like that. Might as well use an array inside of the card. Int 4. So each of these values now is 0, 1 or 2. Could also replace the int with something that represents a modulo 3 integer or z3. But I think we can work around that. I'm not sure if that still compiles, because now this must initialize that array inside it. Let's try that. Doesn't. Oh, the color is not there anymore. apart from this. Start over here. Expected primary expression. I guess it does compile. Yeah, I want to be able to print it anyway, so now we're doing it like this. C4 of characteristics, and we have in total 4 of them. And I want to print maybe a prefix which begins at with nothing. Prefix is empty. And then I'll just print the characteristic of the card. And we'll see. Now we can compile it again, even though. And let's try to print it anyway. So I'm gonna run over all the cards again. No, cards also C. It's called cards in. N is less than card size 20 plus n, and then I want to print cards in, followed by a new line. Let's see, cards in. I guess it works, right? A dot out there. Jet prints it again. $20 cards. Now we pick 3 different cards. 3 meaning we have an N0. And an N1 that is not equal to N0. And reversing it doesn't make any sense either. So I can just do N0 plus 1. That should work. And the third card is N2, which is then N1 plus 1. And I want to know if they are a set. Let's print all the cards if they are a set. Let's first print them all anyway. How to separate my well, with a comma, why not? Cards N1, sorry, N0, N1, and then cards N2. Well, let's just print it. Let's see how it looks like. Yeah, that's just a load of, so there's 1 card, 2 card, another card, and all cards are different, right? So how many should that be? How many? That's a difficult question, actually. So 20 choose 3. And I calculate 20 faculty. It's a bit too big. $1,140. Well, yeah, I guess that's the answer, right? Yep, 1140. So I guess we did it right. And then we have if is set. That's ridiculous. You don't even want to do that, right? Just passing them as an array as well. An array of 3 cards. Everything is an array. Now, to be clear, if these things have no set at all, then this is going to print nothing. None of the 1140 possibilities would be set. And I will be stumped, really. I mean, I kind of believe it already, but... And the point of this stream is to find out where my reasoning went wrong. So what I really want to do is put all 20 in a 4-dimensional space and look at it. Unfortunately, I have to figure something out to make that work. Okay, so when is something is set, passy, nothing. I am doing something. See the description. Some totally different intermezzo. Okay, we have to run over all the characteristics. Check if that one characteristic forms a set. So if that for that one characteristic they are all equal or all different, and if that is not the case, then it's not going to be a set. And otherwise, if it survives all tests, then it is a set. So here we have to test if for that one characteristic it is a set or not. And we know we can do that by adding something, doing it modulo. So we do something and then modulo 3, and then it must be equal to 0. And then actually it must not be equal to 0. If not equal to 0, then we can return false. And then here between the brackets it must be a sum. Okay, now I need my cards as well. So I have a standard array of 3 cards. Where a card exists of an array of 4 characteristics. think that's it. So we have 3 cards. I run over all the 3 cards and I add something up. And well, for the given card, we add the numbers that belong to the current characteristic to the sum. And if that modulo 3 is unequal 0, then it cannot be a set. And if it is correct for all 4 characteristics, then it is a set. Damn it. Okay, well, I could have seen that by eye, but I couldn't believe it, you know, I just could not believe it. Those 20 cards that do not form set. How? Yeah, well, I guess I'll have to print a 4-dimensional cube. Sort of. How is this possible? Okay, maybe you can start with 16 cards that I had in mind, and then see if if at that point indeed I cannot add a 17 card. I mean, then at least I would have been partially correct. And it's brute force. So I'm going to replace this with 16 cards. Let's just make a copy. Card 16. I'm going to put all of the cards in a little cube, which means that's kind of stupid. It just means I don't use any 2s. Seriously? Yeah, that's what it means. So these are 16 cards, and they are all in the corner of a 4-dimensional cube, because none of them uses the value 2 for any characteristic. Now, obviously, I would say, these do not form a set. This will be my last stream if they do. Oops, what did I say? They don't. Okay. And then the question is it possible to add a single card to this and still not have a set? So just pick a random card that has a 2 in it. Must be at least 1 2 in it, because if everything else was already used. Right, so we have all the cards with any 0s and 1s. So you put it 2 here, then it's just going to pick these 2 from the cards that we already had, and then we have a set. See, because the first characteristic is all the same, 0 0 0, and the second is also 0 0 0, and the third is 0 0 0, and the last one is 0 1 2. So either the characteristics are all the same or they are all different. But what I really want to test is any possibility almost wish I could use a multi-loop, but let's not do that. Okay, I'll put the loop around it and on the outside, I guess. Hello. This is the characteristic where we put the 2 in. The 2 in. Yeah, I don't know. It's probably better to do that differently. It's gonna do it like that. Characteristic 0 runs from 0 to 2. Did this before when printing it, when printing all the cards. I'm just going to try all cards. However, if we do not have any 2, so if 0 is unequal to and C1 is unequal to and C3, what am I doing wrong? C1 is unequal to and C2 is unequal to and C3 is unequal to, then we have a card that we already have in our first 16 cards. So I don't want to do that. Just going to continue my loop. Otherwise, I want to put that in card 16 at 16th place as C0, C1, C2, C3. I think that works. Okay. So this one we already saw, that forms a set. And this one forms a set because the same, all of them are 0, 0, 1, 0, 0, 1, 0, 0, 1, and then 0, 1, 2, all different. So every time you see a 2 here, they must be all different. So for example, 2, 2, 2, just 0, 0, 0, all the same, and then 0, 1, 2, or 1, 0, 2, or 1, 0, 2. Yeah, I believe that is correct. However, what I really wanted to know is if there is anyone that does not form a set. So in this case I have to do not. Oh, really? Really? Oh, wait. This is nonsensical. I'm not doing it right. It must not be a set for all of the 16 cards that we have. So what am I trying to do now? No, wait. Okay, I pick a card. I pick a 17th card. This is card number 17. And now I want to know if we still do not have any set, adding that card. So I have to do no set is true. And then if no set, I just want to print out card number 16. And then here we have to do if we have a set for anything, then no set is false. Is that better? So for some given card, which we are going to print here, we're trying 3 cards of all the 17 cards that we have. Might as well just pick the 17 cards always, right? It's just, this is kind of nonsensical to do this, but okay, well, it's fast enough. And then if it is a set, then there is at least one set, if you pick the right cards. So then we don't print it. Yeah, this is what I want. Aha! Whew. Okay, I feel a little bit less bad now. So it is indeed true that if you take these 16 cards, then that's the limit. I mean, not the last one, but these. If you pick these 16 cards, then it is indeed not possible to add any card to it and not have a set. But apparently I still made a mistake then, thinking that it didn't matter. No, I guess next question then is, can we repeat this for 3 dimensions, aka 3 characteristics, and then find cards that are find more than 8 cards. That's pretty heavy brute force. But at least then I can make a drawing, 3-dimensional drawing. Yeah, well, this is just one cube, right? I need a 3 by 3 by 3 cube. I think I need a graphics program, which I'm not very good at yet. It's not gonna work. I think I just give up. Still, you know, at the very least I could write a program, I guess, that just generates all possibilities. That is one big program, I'm afraid. It might be very slow too. Can we write this? Okay, let's start over. Set to. Cannot imagine I need it, but well. increment, compare, what else do we need? Print. Now you have to wonder. Characteristic. Characteristic is like exactly the same as a value of Z3. Maybe I should not define Z3, just characteristic. But then again, characteristic has a name and you have different characteristics. I'm not convinced at all. Okay, what did I want to do? I wanted to brute force every possible combination of n cards. I think the index is not necessary. I might as well delete this at all completely. I mean, it's kind of silly. Substitute set3 with characteristic. Okay, because then we get a card. So wait, it only jumps to the top. God. Let's print a card like that. A bit random, but Default constructed card. I don't think I have any reason to construct a card from it's new of him. But if you just I don't know. I don't have any reason to construct a specific card because I'm just brute forcing every card. So I think I can perfectly well do with just increment as well. I'm not going to support post. I hate post increment. Why I did I even add it? I'm not going to use it. Let's do increment for my card, and that's like it-ish. Okay, and that's C is number of characteristics -1. C is larger than 0, larger or equal 0. Minus C. If something, then break. Characteristics C plus. Yeah, that's correct, right? Apart from that, I cannot compare with 0. You can only compare with a characteristic, say characteristic 0. Warning, no return type. No return. Return this. Okay, let's print pre-increment. And it prints that, of course. Let's do that a few times. Oh, what the hell, man. Line 88. So incrementing my card gives me from 0, 0, 0 to 1 to and so on until we get to a value that is too large. I will just go around, who cares? Maybe I should be able to just, compare with 0 instead of comparing it with 0. Let's say like that. No, the 0 not. So if it becomes 0, then the not operator returns true. Silly, but well, you gotta abuse those operators somehow. Boolean operator not for a characteristic. Not value, I guess. But yeah, I also want to have that for my card. Card is jealous. Wants it to have its own operator not. It seems very silly that I would have to test all of the whole array one by one. But I guess that's what I do. I'm lazy. If return false, otherwise return true. So it's false if there is any that is not 0. Characteristics C. Well, I only had a not operator, so that's 2 nots. If not, then it is not true. Now I'm at it actually. I can just now continue until I'll just do while plus x. Okay, it's annoying that I have to add not everywhere. Let's add a operator bool. Put it down here. I don't know why, but not this. Oh wait, I removed that as well. Okay. I removed the not operator bool. Implicit conversion to Boolean. Return value. And I printed, incremented, and then I printed. No, I just printed. Then I incremented, and then after incrementing, we compare it with 0. And while it is not 0, we print it again. So this should print all the way until the last thingy. Yeah, that didn't work. What the hell's going on here? This looks like random. Why? What is happening here? It incremented everything. And then it started at 0, and then it became a 1, that also. Oh, wait a minute. I think I see it. Yep, I see it. I see it. Now I find it in the code. And that, increment. If not, should be no not. Right. Yep, so we can iterate over all the cards. Isn't that nice? So now I need I think an array of all the possible cards that exist. Oops, array, card. That's, how many cards are there? It's number of so number of characteristics to the power of the number of values per characteristic. Do we have that? Like power or something? Standard power. Base, comma, exponent. Guess it'll work. Yep, it's still working, except that something didn't work. Pau is not a member. CMath. Interesting. It stopped a bit early. Why? Yeah, well, 81. It's a good thing I keep testing. We have all 81 cards. Now, what is next? Can create all possible sets. No. I want to create for a given number of cards just a load of cards. It is probably going to be too slow. I mean, how many ways are there to pick 20 cards from 81? Let's try that again here. 81, choose 20. Too big. Yeah, that's going to be too slow. Too slow. Too slow, too slow, too slow. Better make it a little bit less. 16. Still very, very, very big. I see this and I think, what? It's 1 to the power 4, 2 to the power 4, 3 to the power 4, 4 to the power 4, 5 to the power 4, 625. Can I not calculate anything? Five to the power 4, 625. Answer 1155. Am I crazy? 625. What was I thinking? Oh, there's another. This is another question. Nah. And yeah, I'm kind of stuck here because I happily started to brute force this, but yeah, definitely going to be too slow, right? There must be a smarter way to do it. Suddenly feeling hungry, which might have to do with that I didn't eat anything. And it's too late to cook. Probably should just eat with some sandwiches. Yeah, I feel like I have to give this up. Just return to my Vulkan engine. Because I can put another half an hour into it, or even an hour, and then we'll have a program that is running forever and never ending. And it goes a bit too far to put in more time into it. Like a real project. I have to admit defeat anyway. But yeah, I really wish I could have understood what my thinko is there. With 3 dimensions, that is 3 characteristics. Now, if I already had a nice graphics program, so I could draw a see-through cube with 27 little cubes in it, glowing balls in it. Now we could visualize stuff, but I'm afraid my Vulkan engine is not capable to do that yet. Damn. Yeah, the problem here is I have to admit that I was wrong and then give up searching for the correct answer or the understanding of it. I just don't want to understand it. What is wrong? Oh wait, this is a nice problem to think about while I lay in bed. Yeah. I shouldn't waste it. So I'm going to stop and then first I'm going to eat something. If ever I figured it out, then I'll get back to it, I guess. Okay, yeah, I'll be back later maybe, because I'm going to eat. Sorry for the unsatisfactory end. Thanks for keeping me company here.